In this video we're going to be sketching graphs, straight line graphs, using the gradient intercept method here. Now in order to use this method you need to know the gradient and the y-intercept. Now that may well be that you've got the line or the equation in the form of y equals mx plus c. Just a reminder that m is the gradient and c is the y-intercept. So let's have a look at this equation here. I've written y equals 3/4 x plus 2. Now we can see that it's in the form above where m, the gradient, is 3/4 and the y-intercept c is 2, positive 2. Now let's just go to the gradient first. We can see that the gradient is 3/4. Don't forget that the gradient is made up of rise over run, or obviously the vertical distance divided by the horizontal distance. Now we can see here that m equals 3/4, which means the rise is 3 and the run is 4. So what I can actually do on the graph is I can pick a starting point, but obviously I don't know where to start. A good place to start would be the y-intercept, which we can see here is plus 2. So therefore, already in the equation we can see that the y-intercept is plus 2. So the value of c is 2, meaning the coordinate is 0, 2. So that's going to be my starting point for my rise over run. So I'll put a dot there or a cross. On the grid, don't forget you've got to have it labelled x and y. Now, if I go a rise of 3, literally count, check your scale. Obviously I've got a scale of 1, so I can just count in ones. So I'm going to go up 3, 1, 2, 3, and the run is 4. So I'm going to go from that point 1, 2, 3, 4, and I put another dot there. I'm going to do the same from this point. I'm going to go up 3, 1, 2, 3, and along 4, 1, 2, 3, 4. Put the dot there. And I can similarly work backwards because it's going in a straight line. So the rise was 3, obviously because I'm going back the other way, I'm going to be going down 3, 1, 2, 3, and counting the run of 4, 1, 2, 3, 4, put the line there. Now you should see that it makes a straight line. It's literally a pattern, 1, 2, 3, 1, 2, 3, 4. And then you join the dots up with a line, a continuous line with arrows on it. And there you have it. This is the line of y equals 3/4 x plus 2. Now I'm going to write the actual equation on the line because I'm going to use the same grid to draw my second example. So my second example, again, I'm going to write the equation in a slightly different form. So it's not in y equals mx plus c. It's in that ax plus bx plus y. Ax plus by equals c. Okay, so it's in a different format. And all that means is just rearranging it. So I'm going to rearrange. So I'm going to take the 4x over the other side, because ultimately I want y equals. So I'm left with 3 minus 4x. And then, of course, I'm going to divide both sides by 2. Sides by 2. So I've got y equals 3 over 2 minus 4 over 2, which is minus 2x. And we can see that's now in the form of y equals, here's the mx, and here's the c, because don't forget the gradient has to be next to the x variable. So we have a gradient of negative 2, so our gradient is negative 2, and our y-intercept is 3 upon 2. So there's our starting point, our y-intercept. So I'm going to start at 3 over 2, which of course is 1.5. So on the graph, a bit tricky, but there's 1.5 there, and it's a positive number, so I'll put a dot there. Now, the gradient of negative 2, we've got to turn that into a rise over run. So, of course, turning the negative 2, a whole number, into a fraction means I could put it over 1. That tells me that the rise is negative 2, so it's going to go down, over the run of 1. So, a bit tricky that I'm starting at half point, but nevertheless, let's continue. So, and then we're going to have a negative gradient, so we expect the line to go down. So I've started at 3 upon 2, so I'm going to go a run of 1 and a rise, a negative rise of 2. So 1, 2, and a 1 of 1. So it goes there. Again, going to follow the same pattern. The rise of negative 2, 1, 2, run along 1. So it sits there. And I'm just going to do a few more points first. 1, 2, and run along 1. I'm going to go a few up in the other direction. So of course I'm working back the other way. A run of 1, rise of 2, 1, 2. Do one more, run of 1, 1, 2. And of course I'm going to join that up with a straight line. Okay, there you go. And I've actually done it in green this time. Again, the arrows are either side, and I've written the equation on the line.